All right, all right. Good morning to you all. Kindly come and join in the live. And today we are going to discuss again our exercise number 2.2. So, exercise number 2.2 we have to discuss. So, before going to discuss our exercise number 2.2, we just need to recall our previous ones. Kindly come and join whenever join. You just stay present, sir. Yes, Kushipal, good morning. And what about remaining? Kindly come and join. Kushipal, kindly inform to your friends to come and join so that we'll start our class. Yes, Sauli, good morning. Still anyone? Where is Vinod and Dalia? Sahil, you inform the boys to come and join, and Kushipal will inform the girls to come and join. Garima also not present. Okay, all right. And some students were not sending the names. Okay, okay. Kusum came. Kusum, good morning. Daria, good morning. All right, let me start now class. Then later we'll discuss. So before going to discuss class again, once again we'll recall what is our domain, what is our range, what is our codomain. Here you should understand clearly those. Otherwise, we could not able to solve any problem. So let me explain with the diagram. So one set A, another set B is there. Okay, and set A consisting some elements 1, 2, 3, 4. Set B having like A, B, C, D, E. Okay, so now set A having the relation, one is having relation with A, two is having relation with B, three is having relation with E, four is having relation with C. Okay, first this understand clearly. Good morning to all and understand this clearly. Before going to understand this concept, let us close our eyes. We'll do prayer, then we can start our class. Let us close our eyes. Right. God kindly provide your knowledge and wisdom to solve our mathematics problems and our daily life problems. Thank you, God. Right. So now how many Kushi came, Sahil came, Kusum came, Daria came. Okay. So Garima is still present. Right. So now here set A and this is your set B. And one more thing, remember carefully, you was observing some students were leaving in the middle of the class. Kindly don't leave in the middle of the class because it is mathematics you could not able to understand once if you are present. Kindly be present until the end of the class. And whenever you get the doubts, immediately you can ask so that it is going to be more interactive. Right. So now we'll understand here clearly now. So now A to B, whatever this is called, we'll say that relation. So now relation R is equal to 1A, 1 comma A. These are called as ordered pairs. Then 2 comma B. Next 3 comma E. Next 4 comma C. The relation R map A to B. So relation is from A to B. Now observe carefully here. The way these arrows are started, those we can call it as domain. So now domain is equal to where these all started, those 1, 2, 3, 4. So write 1, 2, 3, 4. This is your domain. And then what is your range? So where these arrows are ended, that is called as range. So arrows are ended here. This is A. Next arrow at B. Next arrow at C. Next arrow at E. So A, B, C is called as range. And now there is another name also for this. Whichever domain place 1, 2, 3, 4 is there. So for example, here 1A is there. So here 1 is one is pre-image of A. A is image of 1. Here, remember, this is image of 1. Then, but this 1 means pre-image of A. Pre means before 1. Okay? So now, in this way, we use in the mathematics language. Okay, so now domain you are understood, range understood, then what is your core domain? Core domain means in the relation, whichever is there in the second, that's full set we can call as core domain. Whether it is having relation, whether it is not having relation, all elements we need to take. So now what are all elements? A, B, C, D, E. Here D is not having relation, but this is also considered when you write the core domain. Okay. So codomain means so whichever the elements are there in the set B, those we can call it as a codomain. So always remember wherever the arrow mark is there, that set completely we can call it as codomain. So now here codomain is A, B, C, D, E. Clear? I hope now you all understood what is domain, what is range, what is codomain. Other names also we can use for the domain. Domain other name is input. So whichever input, so according to input, whatever you get output, that is called as range. Sometimes range is equal to codomain also. Okay. So in which cases codomain range is equal to codomain. Check here 1, 2, 3 A, B, C is there. One is having relation with A, two is having relation with B, three is having relation with the C. We have set A, set B. Observe carefully here now. This becomes as domain and this becomes as range. So now A, B, C, everything having the relation, and this is range is equal to what you get now A, B, C. And then same for domain also. Here all relation is there, so no problem A, B, C. So sometimes core domain is equal to range possibility is there, but always it is also not possible. Okay, so whether it is equal or not equal, range is a different. I hope you understood what is difference between range and core domain. Range means when you give the input, if you get some output, that is nothing but your range. So one I given, I got answer as A. Two I given, I got answer as B. Three I given, I got answer as E. Four I given, I got answer as C. Those we can call it as a range. So now core domain means whether it is having relation or not having relation in the set B, those all elements you can write it as a core domain. Means second set whichever is there in the arrow place, that set completely core domain. Okay, I hope you all understood what is domain, what is range, what is core domain. So let's move on to the exercise number 2.2. I think yesterday we are unable to solve the second problem. The contours we have to discuss, but once again we'll discuss those all problems. So first analysis we'll discuss again, or we need to discuss from second problem. You just inform to me. According to that, I will explain to you. Do you want first problem again? In exercise number 2.2, first problem, do you want again? Or I'll go for the second question. Firstly, inform to me. Daria, Kusum, and Sahil, Kushipal, Garima Singh, if you are present, you can also say. So kindly inform to me. Vinod, if you are present, you can also inform to me. Second question I was doing, first also do you want? Inform to me first. So I'm waiting for, okay, first one you don't want. Okay, second answer, can we start then? Inform fast. Firstly, only Kushipal answered, remaining nobody is answered. Sahil, Sahil, you want that? Fastly inform to me. I need your response. Without your response, yes sir means what is yes, what is no? This is what I'm not understanding here. So I need clearly that is you want first problem or not. If you don't want, then it's okay. If you want again, I will explain. Okay, no worries. I think minus one now means let me explain again first answer. It is going to be good for you all. Exercise number 2.2, first question listen. Let A is equal to the given 1, 2, 3, and so on, comma 14. Define a relation R from A to A. So R maps A to A they given. So R is equal to x comma y such that 3x minus y is equal to 0 where x comma y belongs to A. This is what they given. Write its domain, codomain, range, and range. Alright, this we need to find out and just observe carefully first. So first, what is domain, what is codomain, what is range, this we have to find out. And it is very simple, just observe carefully now. So whichever the equation given that right first, 3x minus y is equal to 0 they given. So now 3x is equal to what you get? Y. So 3 times of x, whatever is there, that is going to be your y. So now here it is 1 to 14 numbers are there. So we'll check here. First I'll write here relation is A to A. This is some relation R. So what are the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Anyhow, I'll increase this. 12, 13, 14. So this is your set. So I'm not drawing properly this diagram. You need to draw in your uh, notebooks properly. So first always understand the diagram at a form, then it becomes easy. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Right? So we written here 14, here also 14. Now observe carefully what I will do. So now first here 3x is equal to 1 take. So 3 into 1 y. So that means 3 is equal to y. When x is equal to 1, y is nothing but 3. 1 comma 3 is your first one. Then x is equal to 2, take what you are going to get. So 3 into 2 is equal to y, 3 to 6 is equal to y. So next one it is x is equal to 3, take. 3 into 3 is equal to y, that is 9 is equal to y. Then 3 into 4 is equal to y, that is 12 is equal to y. 3 into 5 is equal to y, that is nothing but 15 is equal to y. Observe carefully here. 15 is there anywhere in this? So not there, so that no need to take this. Except that remaining we can write. So here 4 means 12, so 4 comma 12. And here it is 3 means 9, so 3 comma 9. And here 2 means it is 6, so that 2 comma 6. So now our relation is 1, 2, 3. First 1, 2, 3. First one. Second one 2 to 6. So 2 to 6. Third one 3 to 9. 3 to 9. And next fourth one 4 to 12. 4 to 12. Then remaining we could not able to get that. So now what is our relation R? So at last here I write relation R is equal to 1 3. Next 2 6. Next 3 9. Next 4 12. Right? So you got relation in this now. What is your domain? Domain is equal to 1, 2, 3, 4. Whichever the first one are there, or arrow starting numbers are domain. So 1, 2, 3, 4. Remaining places arrow is not static, so no need to write that. So now 1, 2, 3, 4. Then what is your range? So this one is having relation to the P. Simply what we need to do is all x's we can say that if I take this as x comma y, all x's will take as domain, all y's will take it as range. So now what are the 3, 6, 9, 12? Check here 3, 6, 9, 12. So write 3, 6, 9, 12. That is your range. Then what is your codomain? So codomain is equal to what is relation here? A to A. So what is here? Arrow mark before A is there. Completely that A, whether it is having relation, whether it is not having relation with the pre-images, we will write all the A's. Okay. So now what are those? 1, 2, 3, 4, and so on, comma 14. So means 1 to 14 all numbers we can call it as a codomain. I hope you all understood now. Right. So I hope you all understood this. So this is your domain, range, and your codomain. Okay. So now same manner, I'm going to give now for you some other questions you have to solve and inform to me what is your answers. Okay. Let me do in this way so that you can understand clearly. So I'll write same question only, but little changes I want to make. So you have to inform that. So now in this question they given like 2x minus y. 2x minus y is equal to 0. What is your answer? Inform to me now. 2x minus y is equal to 0. What is your codomain? First codomain inform to me, then domain and range you can solve and inform. So now first tell to me what is codomain. Here 2x minus y is equal to 0. So what should be my codomain? Codomain, any changes will be in codomain or not? I want only codomain so that I can understand whether you all understood concept of domain, codomain, range. So I want only codomain. Kushi, can you tell what is codomain for this first question? Means which I given now that change it up to 2x minus y is equal to 0. Same as A. Very good. So Sahib done good job. And what about Kushi answer? Same as A means. So which number? Means 1 to 10 or 1 to 11. Very good. 1 to 14 is correct answer. Sahil understood concept very well. What about Kushipa? You are understood or not? See whether this element, whatever you change also, this codomain never changes. So whatever is there here, that only your codomain. So that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, whichever is there up to 14, you have to write. No changes in codomain. Very good. So changes not there in the codomain. Only domain and range will be changes. So what are that? 2x is equal to y you can write. Then x is equal to 1 means it is x is equal to 1. So y is 2. X is equal to 2. Then y is 4. Then x is equal to 3. Then it becomes as 6. X is equal to 4. Then y becomes as 8. X is equal to 5. Then y becomes as 10. Then x is equal to 6, y becomes as 12, x is equal to 7, then y becomes as 14, x is equal to 8, then y becomes as 16. We cannot consider this because there are elements up to 14 only. Okay? Kushi, once again observe carefully here. Domain means where the relation is started, that points only. So only these points we can say as a domain. And whichever here ended. So here 3, 6, 9, 12 is there. These called as range. But codomain means whichever here arrow mark before whichever set is there, that complete set we can call it as a codomain. Okay. So now you can observe carefully what I was done here. This 2x minus y is equal to 0 minus y total that's plus y. So 2x is equal to y you got as a your answer. So then what you need to do substitute now here 1 to 14 is there. Input as 1 to 14. Just you need to substitute in this equation to get the y value. So after getting y value, whichever the values you are getting for that we have to give the relation. Otherwise we cannot give the relation. So now here for that how I will give relation observe carefully now. So now for which question I was given for that now answer. So observe this carefully now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Right? So now first one is capital A to A is relation. Capital A to A having relation R. Okay? Now, first one, if you take what is your y2? So 1, alright, mistake. 1, 2. This is your relation. Next one, 2, 4. 3, 6, 4, 8, then 5, 10, 6, 12, 7 is 14. Then after that, whichever is fewer that we cannot take. So now that was the reason we written here, whichever here now in the first set A having the relations, those elements are domain. So domain is equal to 1, 2, 3, 4, 5, 6, 7. Okay, and range is nothing but 2, 4, 6, 8, 10, 12, 14. Okay, so these 2, 4, 6, 8, 10, 12, 14, these are called as range, and whichever completely is there in this set that is called as your codon. So now inform to me, Kushipa, you are understood or not this? Kushipa. So let me know whether you are understood or not, then we go for next. Otherwise, without understanding, if we go for others, it was very difficult. So if you are understood this, then we go for next. So that next problems when you are solving, everything becomes as easy for you. Yes, sir, understood. Okay. So now we go for our next problem. So that is about your first problem. The now one was little fastly I go. Can we concentrate because today, yesterday also we lost our class because of internet issues. But today we have to complete this exercise. Now, second question, what is the given? Define the relation of onset n of natural numbers by relation r is equal to x comma y such that y is equal to x plus y. Sorry, x plus 5. X is a natural number less than 4. Less than 4. X comma y is belongs to natural number. Depict this relationship using roster form and the domain and range. You need to write only domain and range. It is very simple. So this statement x is a natural number. See here x comma y given. So always remember whenever x comma y given, x is always input. Input or your domain. And y is always your output, or we can say this as a range. Okay? So now, what is your domain? It is given here indirectly. X is a natural number less than 4. Less than 4 natural number means let me say this as capital A is equal to. So less than 4, what numbers are there? One, 2, 3. These only less than 4 natural numbers. So we have written that is only 1, 2, 3 because here x is a natural number less than 4. Less than 4 means only up to 3, not 4. Okay. So that's why 1, 2, 3 written. Then now here what is relation given? Y is equal to x plus 5 again. So first x is equal to 1, y is equal to 1 plus 5, that is nothing but 6. So that is 1 comma 6. Next y is equal to x plus 5, x is equal to 2 because here 2 is there. So y is equal to 2 plus 5, y is equal to 7, that is 2 comma 7. And go for next, y is equal to x plus 5, x is equal to 3. So y is equal to 3 plus 5, that is y is equal to 8. So 3 comma 8. So simply what we need to do is for this just add 5. So 1 plus 5, 6, 2 plus 5, 7, then 3 plus 5, 8. So you can check 6, 7, 8. So now first relation R is equal to 1 comma 6, 2 comma 7, next 3 comma 8. Now tell to me what is domain? Domain of R. Domain of, sorry, range of R. So domain of R 1, 2, 3, range is 6, 7, 8. So who are written these answers, that student is correct. And remaining kindly rectify your answers. So you have understood now? So first clue for domain is this. X is a natural number less than 4. Less than 4, what numbers are possible? 1, 2, 3. Because natural number starting from 1. So that was the reason 1, 2, 3 written. Then they given for you y is equal to x plus 5. So that just y is nothing but your output or we can say as a range. So now x plus 1. So now first here x is 1, 1 plus 5 is nothing but 6. Next 2, 2 plus 5 is nothing but 7. Next 3, 3 plus 5 is nothing but 8. So now our relations are 1, 6, 2, 7, 3, 8. After writing that all x's right, that is your domain, all y's right, that is your range. So that is about it. And if they ask, what is your codomain? Here they've given natural number to natural number so that all the natural numbers we can say as a codomain. But they were not asked, so we don't need to write it. So understood this? Yes. Yes, correct. You are. Sai, you are correct. I hope you all understood this. If you are understood, just give the thumb symbol so that I can understand. Otherwise, I could not able to understand that. So I think the idea was said. And what about Kushi and Garima is present or absent? I don't know whether Garima is present. Just you also inform to me. And Kusum, you are understood or not? I was not able to call you again. So if you are present, inform to me, Kusum, whether you are understood or not this question. So now your turn. So you have to do in this way. So now your question is, it is natural number less than 7. Natural number less than 7, and this becomes as relation as x plus 1. So natural number is less than 7 and your question is y is equal to x plus 1. Don't write this all in your notebook. Do in your rough work and then tell to me your domain and range. So what is your domain and range for this? So if y is equal to x plus 1 and here we given x is a natural number less than 7. So tell to me your answers fastly. So what is your domain? What is your range? Very simple question it is. So if anyone knows, inform to me. Already it was written, Sahil written 1, 2, 3, 4, 5, 6. Okay. And 2, 3, 4, 5, 6, 7. Correct. Codomain also correct. So Sahil is understood completely the concept. So what about remaining? All right. So you are not informing to me, so that let me go for our problems. If I'm doing like this late, it is not possible to complete our syllabus. Within 30 minutes, we have to complete up to 9 problems. Okay. So I hope these two you are understood means it's enough. You can understand the mind more. All are easy next. So only this part you have to understand. Right. So now listen, your problem number 3, capital A is equal to 1, 2, 3, 5, capital B is equal to 4, 6, 9. Define a relation R from A to B. So R is A to B. Then R is equal to x comma y such that the difference between the difference between x and y is odd. X belongs to A, comma y belongs to B. Write or in roster form. Write or in roster form. So here set builder form the given, we need to write in roster form. How to solve this? Observe carefully everyone now. So she what was written? Kushi, that is a range count. It is 1, 2, 2, 3, 3, 4, whichever you are written. Those we can call it as relation, capital R. And range is nothing but whichever the second elements are there in that ordered way. So 2, 3, 4, those are we can call it as a range. And 1, 2, 3, whichever you are written, that is called as your domain. Okay? Alright. So now observe carefully. So now what is your answer? So it is very simple. Just observe in the diagram we can understand A and B. 1, 2, 3, 5, 4, 6, 9. So this is some relation or what is the relation they say? Difference between x and y is odd. So now 1 minus 4 you get as odd number. 1 minus 6 also you get as odd number 5. And then 1 minus 9 is 8, so that we cannot take. Then 2 minus 4 even number. 2 minus 6 also even number. 2 minus 9. 9 minus 2. How much it is? 7. So 7 or minus 7, that is your odd number. And next check 3 minus 4, you are going to get one odd number. And then 3 minus 6. So 3 minus 6, how much you are going to get? Minus 3. Again, it is odd number. Next, 3 minus 9. So that is you are going to get as 6. That is again odd number. Next one, 5 minus 4. So 5 minus 4 is nothing but 1. Then again here also possibility is there. So 5 minus 4 you are going to get as a 1. 5 minus 6 again minus 1. This is also again your uh, difference is 1. That is odd number. 5 minus 9. 5 minus 9 is 4. It is not odd number. So whichever the relations or possibility happen, those all we have to write now. So then only you are going to get your answer. Otherwise, it is not possible to get your answer. Okay. So now I need to write in roster form. I'm going to write observe carefully and then you can check again whether you are going to get odd number or not. Here they were not mentioned odd natural number. If they are mentioned odd natural number, then we cannot take the negative numbers which you are going to get. Okay? So if odd natural numbers are not there, then we have to use those ones. Okay. So now what is relation R? R is equal to what relations are possible? First 1 4, next 1 6. So right here 1 comma 4 when you subtract. See the 4 minus 1 you can do 3 you will get 1 minus 4 you get minus 3 you get both are odd numbers only. So odd integers. But here they were not mentioned it is odd natural number. If they give an odd natural number we cannot use this because negative numbers you are getting so that we cannot use. But here it is not mentioned odd natural numbers so that we can use all the numbers. So 1 comma 4 here we will get the difference as odd number. Then next again 1 minus 6 again you are going to get odd number. Next go for next 2 minus 4 not possible, 2 minus 6 also not possible, 2 minus 9 is possible. So 2 comma 9. Next one 3 4. Next one 3 6 not possible. I think 3 6 is possible. 3 minus 6 6 minus 3 3. So possible. So 3 comma 6 is possible. 3 comma 9 odd number possible. 3 comma 9 odd number possible. 3 minus 9 6. 6 is not odd number. So that it is not possible. 3 comma 9 not there. So 3 comma 9 relation is not there because difference you are not getting the odd number. Next one 5 minus 4 1 it is possible. So odd number you are going to get. Next 5 minus 6. So there also you are going to get odd number. So not possible. So these many relations are there. Whatever relations here it is. So 1 comma 4 you are going to get answer as what answers? 1 minus 4 is nothing but minus 3. 4 minus 1 is nothing but 3. Okay, and here 1 minus 6 is nothing but minus 5. 6 minus 1 is nothing but plus 5. And here it is 2 minus 9 is nothing but minus 7. Then 9 minus 2 is nothing but 7. 3 minus 4 is nothing but it is minus 1. 4 minus 3 is nothing but plus 1. 3 minus 6 is nothing but 3. Minus 3, 6 minus 3 is nothing but 3. 5 minus 4 is nothing but 1. 4 minus 1 is nothing but minus 1. 5 minus 6 is nothing but, sorry, yes, 1 and then minus 1. See here 5 minus 6 is nothing but 5 minus 6. So minus 1, 6 minus 5, 1. You are observing all the places you are getting odd number. So either you are subtract with x minus y or y minus x. However, you are getting a odd number. That was the reason these are relations. Okay, available relations are these. Okay, clear? I hope you all understood now. Any doubt in this? So they given in your relation that is x comma y such that this is your so set builder form they given. So we are written as roster form. So here what that is difference between x and y is odd. So x and y should be odd. We need to get that's what we have written this on. Okay. So I hope you all understood what I was written. Sir, you have matched one from which numbers? Very good. So once again, listen this carefully. So this is very important for you all. That's the reason I said understand through the diagram. You can understand clearly. So 4, 6, 9, right? So first with one, what were the relations possible where you are going to get odd numbers you have to check. 1 minus 4 odd number possible. Next, 1 minus 6 also odd number is possible. 1 minus 9, is there any odd number possible? Not at all possible. So then 1 completed. Then go for 2. So 2 minus 4 is 2 not possible. 2 minus 6 is nothing but 4 that is also not possible. Then 2 minus 9 is nothing but 7 so that here relation is possible. Clear? So now what I am doing it is by using one first I am checking 4, 6, 9. Then next by using 2 again checking for 4, 6, 9. And by using 3 again we have to check 4, 6, 9. By using 5 again we have to check 4, 6, 9. Okay? So now first 3 minus 4, 1. And then 3 minus 6 is nothing but 3. 3 minus 9 is nothing but 6, so that we don't want to use. Next, 5 minus 4 is nothing but it is 1. And then 5 minus 6 again it is nothing but minus 1 or 1, whichever odd number. And then 5 minus 9 is nothing but minus 4, it is not odd number. So that was the reason I written all the relations here. 1 4, 1 6, 2 9, 3 4, 3 6, 5 4, 5 6. So then you are going to get your odd numbers. Otherwise, you cannot get odd numbers. Clear? So that is about your problem number 3. Let's move on to the problem number 4. I hope you all understood this problem number 3. Now we are going to the problem number 4. Right. So now problem number 4. Figure given, that figure is this: 5, 6, 7, 3, 4, 5. Now first 5 to 3, next 6 to 4, next 3 7 to 5. So first one they written in set builder form. So this is P set and this is your Q set and this will be some relation. So what they given it is the figure 2.7 shows a relationship between the sets P and Q. Write this relation in set builder form. So first we need to write in set builder form. It is very easily is there. So R is equal to 5 3. Next 6 4. Next 7 5. Written relation. After writing relation, what is the given? So second one it is roster form. So first they said write this relation in set builder form, and second one it is roster form. So I was written for second one answer roster form. I need to write in set builder form. So set builder form R is equal to, first you check what is your finding here common. So 5 minus 3, 2, 6 minus 4, 2, and 7 minus 5, 2. That you are understood that in everywhere y is equal to x minus 2. So you can check now. So 5 take 5 minus 2 is nothing, comma, y belongs to q. So if you are written that, that is your set builder form. What is here? X comma y such that y is equal to x minus 2, where x belongs to p, y belongs to q. So if you are written that, that is your answer. So already one student was written x minus y is equal to 2. Yes, whichever it is possible you can write. So you can write y is equal to x minus 2. You can write it as x minus y is equal to 2 also. That is also correct only. So whichever you want to write, you can write it. So x minus y is equal to 2 written, that is also correct only. So that is about your problem number 4. So and what is its domain and range? So at last one, domain is equal to domain R. So here domain of R is equal to, R is nothing but here relation. 5 6 7. Range of R is equal to 3 4 5. So domain is 5 6 7. Range of R is 3 4 5. So this is your domain and this is your range. So that is about, yes, 5 6 7 is your domain and range is 3 4 5. So that is about your problem number 4. And now we are going to discuss our problem number 5. So I said we need to complete our all problems in today only, not about tomorrow. So let me complete now. It's the fifth question. So we have still, I think, some 15 minutes is left. Within that time, we have to complete. So now, problem number 5. Let capital A be given by 1, 2, 3, 4, 6. Let R be the relation on R defined by. So relation R is A comma B such that A comma B belongs to A, comma B is exactly divisible by A. So we need to find exactly divisible by A. So this B exactly divisible by A. So that is nothing but here. It is remember here A comma B belongs to A means that relation R is A to A. So relation R is A to A and the B is exactly divisible by A we need. Means we need reminder when you are divided B with the A, you have to get the remainder as 0. That means this what is meaning of this is B need to be divided with A, you have to get remainder should be the 0. If you get remainder is 0, then it is exactly divisible, otherwise it is not exactly divisible. Okay? So now how to solve this? Observe carefully and what I need to find. First, relation in roster form, then domain of R, range of R. Simple. So now first I need relation in the roster form. Before going to get that, draw the diagram, then it becomes easy for you. 1, 2, 3, 4, 6. 1, 2, 3, 4, 6. Okay. So one table. So now it is a B need to be divided with A. Exactly that is also. So let me check now what are the possibilities to write our divisibilities. So B need to be divisible with that ACD. So 2, 1 is divided with 1, sorry. This 1 is divisible, exactly divisible by 1, so that right. And 2 is divisible by 1, 3 is divisible by 1, 4 is also divisible by 1, 6 is also divisible by 1. So you can write these all are divisible by 1. So simply we can write 1 comma 1, 1 comma 2, then 1 comma 3, 1 comma 4, 1 comma 6. So observe carefully here 1 you write and 1. So B is here 1 and A is 1. So whichever the first ones are there that is A, whichever second ones are there that is your B. So now with 1 you divide any number you will get exactly divisible. Okay. Next go for 2. 2 divisible with 1 not at all possible. Okay, to divide with 2, yes, it is possible. So you can write 2 comma 2 possible. Next, 2 upon 3 it is not possible. 2 upon 4 it is possible and 2 6 is possible. So 2 4 2 6 is possible. Next, 3 table 3 upon 3 is possible. First one 3 3 possible. Then 3 twos are 6 possible, so that 3 comma 6 is possible. Next, 4 table 4 upon 4, so that is 4 comma 4 is possible. Next one, that's it. Next 6 table 6 upon 6, 6 comma 6 is possible. So write 6 comma 6. These are divisible. So now we can write this as relation or in roster form. First one done. And second one, what is the domain of R? Domain of R. So here repeated numbers we need to write only once. Repeated numbers we have to write only once. So now you can check here one only. Two, only two. Three, only three. Four, yes, only four and six. So 1, 2, 3, 4, 6 is nothing but your domain R. And what about your range? So range of R is equal to. So range of R also 1, 2, 3, 4, 6. All the places same method. So now we can write which are repeated only once we have to write again 1, 2, 3, 4, 6. So domain of R also same and the range of R also same. So 1, 2, 3, 4, 6. So I hope you all understood this. So this is about your relation and domain and then range. So that is about your problem number 5. This is your problem number 5. And now 4 problems are left. Let me complete it now. So now sixth one, determine the domain and range of the relation. It is again simplest question. Sixth one is very simple. So I try to complete. So sixth one here. What about seventh? And seventh also easy. Sixth and seventh very easy. So sixth one they given capital R is equal to x comma x plus 5. Easily they given. Such that x belongs to 0, 1, 2, 3, 4, 5. That's it. And find domain and range. So I need to find here domain and the next one it is range. And our seventh one. So meanwhile you complete your domain and range and let me check their answers. So write the relation capital R is equal to x comma x cube such that x is a prime number less than 10. Prime number less than 10. Find the number of, okay, it is in roster form. So write in roster form. Write in roster form. Simple. Simple questions are given. If anyone is answered, it will be very good. If you are not answered, also it's okay. No, not to worry about anything. So first domain. So here very easily given. So no need to check anything. First I'll write the relation. First here, what is x here? First take 0, next 1, next 2, next 3, next 4, next 5. So 0, comma. So I'll write here 1, comma, 2, comma, 3, comma, 4, comma, 5, comma. Okay? So this answer will complete. Now check here 0. 0 plus 5. So that is nothing but 5. 1 plus 5, 6. 2 plus 5, 7. 3 plus 5, 8. 4 plus 5, 9. 5 plus 5, 10. You got all answers? So now what is your domain and what is your range? Domain of R, range of R. So this all you have to practice, then only you are able to get answers easily. So domain is nothing but 0, 1, 2, 3, 4, 5. 0, 1, 2, 3, 4, 5. And what about range? 5, 6, 7, 8, 9, 10. 5, 6, 7, 8, 9, 10. Clear? That is about your domain and range. So once again, listen this carefully. Here it is given as x and then your y, that is whichever the range is given as x plus 5. So what I was done here, it is x means 0, 1, 2, 3, 4, 5. That is only the given x is belongs to. So 0, 1, 2, 3, 4, 5 written. Next x plus 5. 0 plus 5, 5. Then 1 plus 5, 6. 2 plus 5, 7. Next 3 plus 5, 8. 4 plus 5, 9. 5 plus 5, 10. Clear now? So after getting this, we need to write what is the domain of R, what is your range of R. Domain of R means which are the first elements. For first elements, we call it as a domain. So whichever second elements, the result which was there, that is your range. Clear? So that is about it. And next we will go for our prime numbers less than 10. So first I'll write here prime numbers less than 10. So less than 10, what are prime numbers? 2 is one prime number, 3 is one prime number, next one it is 5 is one prime number, 7 is one prime number. After that, no other prime numbers. So here prime numbers less than 10 is nothing but 2, 3, 5, 7. That is nothing but your input. Input is nothing but what we can call this is your domain. So anyhow I'll write here relation capital R is equal to in roster form x comma x cube. X is here 2, so that 2 comma 2 cube. Next 3, 3 comma 3 cube. Next 5, 5 comma 5 cube. Next 7, 7 cube. So this is your relation. So still, if you want to simplify, you can simplify 2 comma 2 to the 4, 4 to the 8. So 2 comma 8 is first, 3 comma 3 3 is a 9, 9 3 is a 27. Next 5 comma 5 is 25, 25 5 is a 125. So next to 7 table, 7 comma 7 is a 49, 49 into 7, 7 9 is a 63, 7 4 is a 28, 28 plus 4, 28 plus 6, so 34, 3, 43. So this is your relation. So they said just you need to find the relation R, so we found only relation R. Clear? I hope you all understood this. So that is about your problem number 7. So now we are going to the 8 and then 9. It is very easiest ones. So this will complete and it is going to be finished now within the time itself. So still we have I think 2 minutes. So within that time I think we are going to complete it. Okay, problem number 8, listen. Let capital A is equal to x, y, z. Capital B is equal to 1 comma 2. Find the number of relations A to B. So I need to find number of relations. So A to B. So if you want to find number of relations, listen carefully now. Set A elements, number of elements in set A is n, number of elements in set B is n, number of relations. Total number of relations. You have formalized this, remember this. So relations is equal to 2 power mn. So this is your formula. According to that, we have to solve now. So now number of elements in set A. In set A, how many? 1, 2, 3. So that write 3. So next number of elements in set B. How many? 2. So that right here 2. So number of elements in set A is 3. Number of elements in set B is 2. So now total number of relations A to B is equal to 2 power. So number of elements in set A, this is equal to n, this is equal to n. So mn, that is nothing but 2 power 3 into 2, that is 2 power 6. So that many relations are possible. So I hope you all understood this. How many relations? So it is a depend on the number of elements in set A and set B. Set A here it is 3 and set B here it is 2. And set A elements are m, set B elements are n is there. And total number of relations are 2 power mn. But here m means how many? 3 and n means here two elements. So just you can substitute m and n values in the formula. 2 power 3 into 2 is equal to 2 power 6. Now my question for you all, capital A is equal to the given 1, 2, 3, 4, 5. Capital B is equal to the given A, B, C, D, E. Then how many number of relations are possible from A to B? Can anyone tell? So apply this question knowledge to this, then you will get your answer. I don't want simplest form. Without simplest form, I need your answer. So that means here I was written 3 into 2 is 6, that is only 2 power 6. So 2 raised to power 6, in that way you can inform to me for this also. So to the power of how much? How much? 2 power 25. Okay, very good. You are doing good job, madam. So here 5 elements and here also 5 elements. So 5 into 5, 25. So here m is equal to 5. N also is equal to 5. So 5 into 5, 25. So 2 power 25 elements are possible. Means that many relations, so not elements. 2 power 25 relations are possible between A and B. Okay? Right. So Kushipal written 25, it is not 25, 2 power 25. Okay? Right. So that is about your question number 8. And now we'll go for question number 9, which was the last and final. And answer also that much difficult answer. You never ever expect that much difficult answer. Hmm? Very, very difficult answer for last question. So, what is this first? Let me read the question. Let R be the relation on Z. Z is nothing but, in other words, we can call it as the Z. Okay. So, let R be the relation on Z defined by R. Z we can say or we can say Z also. So, here capital R is equal to A comma B such that A comma B belongs to Z. A minus B is an integer. So it is very, very difficult question I said, right? So how much difficult you just listen carefully now. So everyone listen this carefully. R is equal to A comma B. A comma B belongs to the Z. Z is nothing but integer. A minus B is an integer they given. So here, have you remembered one property which you have learned in your sixth class? So that sixth class, I hope you have learned one property that is about integers. Have you learned any property about A minus B is an integer? Have you remembered anything? If you have not remembered, listen that property is what? So that property says that subtraction of any two integers always integer. Remember it. Subtraction of any two integers always integer. If you remember that, I think your answer you got. So remember, we know that, and right here we know that subtraction of any two integers always an integer. Always an integer. If you want, let you check now. 0 minus 1, what you are going to get? Minus 1, that is integer only. You want another one, minus 1, minus 2, that becomes as minus 3, that is again integer. Minus 1 plus 4 is there, that is 3, again it is integer. So from this, what you are understood, from minus infinity to plus infinite, whatever it is, here you are finding here it is all are integers. So you are going to get all differences as integers. From this, what they said to find? What is the domain? What is the so minus infinite to infinite? You written that is correct only, but we could not write in mathematical language in that case minus infinity comma infinite. So if you want to write minus infinite to comma infinite, there x belongs to integer z. You need to write. So simply what I write here, domain of R is equal to Z. Domain of, sorry, range of R. Range of R. Also Z. Here also integer minus infinity to infinity, all integers whichever is there. And range of integer also you are going to get all integers whichever possible. How much you have, you need to have patience to do all the subtractions of the integers. If you want to do, you can do. So that I think you are lifelong, you can do that all subtractions. Right? If you want to do that up to infinite. Right. So that is about your answer. What is your answer for this relation? Domain of R is equal to Z. Range of R also Z. Z is nothing but here integer. So you have understood what I said here. So here A and B belongs to integer they given. Okay. So A is your input, B is your output. And I was searched whether it is integer possible or not. The relation they given A minus B as an integer. So A minus B is an integer or not, you have to check first. That is what they given relation. So now what I will do here is any integer you can take and you can find and you will get answer only integer. So that was the reason. Thus we conclude on that time domain of R is integer. That means Z minus infinity to plus infinity. You can use anything. So now range of R also you can use any number minus infinity to plus infinity. That was the reason. Instead of writing those all big numbers, we were written here it is domain of R is equal to Z, range of R is equal to Z. If you want to write whatever something written in that way, also write minus infinity comma sorry, minus infinity dash dash infinity was written in the middle. We can write 0, one side minus 1, other side plus 1 also. So then it is going to be same answer. Okay. I hope you all understood. And anyone is not understood, inform to me now itself. Pushipal, you are understood this or not? If you are understood, inform to me. Okay, you are understood. Thank you, sir. Saying okay. All right, that is about today's class. We completed this exercise number 2.2. And for your full clarity purpose, this domain range codomain PPT I was sharing to you all. So kindly go through that PPT. After this, I am going to share in your group. So go through that, understanding what is our domain range and your codomain. And even with that, you can learn what is function also. So that tomorrow I don't want to discuss with you all what is function. So we just directly go through that exercise number 2.3. Once it is completed, miscellaneous exercise, your homework. After that, we complete. Okay. All right. May God bless you all.